Okay, good afternoon, everyone. You're seeing this Tuesday afternoon or Wednesday morning. We talked about the formation of the universe. You did your readings on the structure of not the universe, the solar system. So you did the formation of the solar system. You done your readings on the structure of the solar system. So today's lecture is going to kind of be more in the structure of the solar system, where we're going to talk about what classifies things as asteroids, comets, and planets. Next slide. So asteroids, right? We classify them relatively small, predominantly rocky objects that revolve around the sun. Okay? Relatively small, but small when we're referring to something as big as a planet, right? But asteroids can be massive. Okay, they generally orbit between Mars and Jupiter in the asteroid belt and in a prograde orbit, meaning they're spinning around the sun in the same direction as the planets. Right? Of course, there's going to be some few exceptions, individual rocks that got bumped out of their position, right, or got pulled out by gravity from other planets. In terms of size, a few are larger than 300 kilometers in diameter. So that's from, say, Sarnia to Toronto, but most of them are much smaller. Largest known one, Ceres. You can see a picture of Ceres here. It's almost 1,000 kilometers across, 940, right? With a strong enough gravity to pull itself into a sphere, right? Its own gravity is pulling on all its matter into a sphere. Okay. So this next image here is actually, let's see if I can get a little closer here. Zoom, cancel that. I'm zooming on the wrong side. Zoom, too much. Zoom out. 100%. Okay. Okay. So here we have Ceres, sorry, another large one, Vesta, right? And we can see, you know, asteroids getting smaller and smaller. Still, these are, very, very big. This is almost 1,000 kilometers across. This is about 300 kilometers across, right? Maybe less than 100 here, and so on. Right? Still huge pieces of rock. Okay, so the asteroids are found in a compact concentration, again, the main asteroid belt between Mars and Jupiter. Okay, this suggests that they may have been fragments of a planet that was broken up. So there was a planet forming between Mars and Jupiter, and for some reason, that planet was shattered. Okay, maybe because of the strong gravitational pull between the inner planets and Jupiter. The other idea, these are primal rocks that never managed to coalesce into a planet due to the gravitational pull of Jupiter. Right? So a planet wanted to form there, right? But the gravity was too strong and it never gave it a chance. Okay? A lot of the ideas are that this is much more likely that there never really was a planet there, because if there was a planet, we would expect the asteroids to. Okay, let me rephrase that. If there was initially a planet there that was shattered, we'd expect all the asteroids to have a similar composition because they came from the same planetary body. Right? But the asteroids in the asteroid belt, they're not uniform. They don't have a uniform composition. So it's probably that they didn't arise from a single body that shattered, but it's much more likely that they are rocks that were formed in the very early solar system, and they never coalesced into a planet. They never pulled each other together to form a planet due to the gravity of Jupiter. Okay, the physical properties of asteroids. In general, asteroids are too small to be resolved by Earth based telescopes. Okay? Aside from things like Ceres, right, being so large, most asteroids are too small for us to track them in space. Okay? Our telescopes really struggle to find them. So because they're small, right, it can be difficult for our telescopes to track them and gain information. It is known that they differ from the planets and the moons, but they also differ amongst themselves. Asteroids, by their spectroscopic analysis, so looking at the light that bounces off of them, come in like three basic categories. Like the C type or the carbonaceous asteroid, they are dark and very non reflective. And we say about 75% of the asteroids are carbonaceous. Okay. S types, more reflective. Okay. So they're made up of shinier rocky material, right? Like silicates, right, that have a little more shine to them than, things made up like limestone, like a carbonaceous asteroid. Or they are M type, right? And these M types tend to be shinier, right? And they're made up of metals, right? Like nickel and iron. And 10% of the asteroids in that asteroid belt are thought to be M types. So we got C type, right? Very dark. They're the carbonaceous. S type, made up of silicates, right? And then the M type, made up of metals. In general, S type asteroids dominate the inner regions of the asteroid belt, so the silicates are found more on the interior of the belt. And as we go deeper and deeper into space, we see more and more carbonaceous types. And they we can't go out and travel to each asteroid and measure them. So we estimate their size by the amount of energy that they reflect, right? So the amount of light and heat that bounces off of them gives us a way of estimating how big they are. Okay. So let's just zoom in on this image here. Get a little larger. Nope, not on that. I don't want to zoom in on the side panel. I want to zoom in on this panel. So let's shrink that down. This panel. Zoom. Let's go 100%. Okay. So this is just putting Ceres into the scale, Ceres and Vesta with our planets. Right? So Mars being smaller than the Earth, Mercury, Earth's moon, right? So if I look at Ceres, it probably looks like about a tenth maybe of Earth's moon. So it's quite big. And then there's Vesta, which was shown in the earlier slide. Let's go back here. Okay, the first close-up views of asteroids were provided by the Galileo probe. Don't bother memorizing that. Okay, so most asteroids are within the asteroid belt. Okay, but we got what we call Earth-crossing asteroids. So some asteroids have highly elliptical, that's spelled incorrectly, highly elliptical orbits that have been affected by the gravity, right? Affected by the gravity of Mars and Jupiter. So the gravity of other bodies and maybe even physical contact between each other have pushed asteroids out of their stable belt orbit, and their orbits have become elliptical instead of being circular, right? They've been squished into ellipses, and these orbits may take them into Earth's orbit. Okay, Earth's orbit shown in blue here. Right? There are many asteroids that cross Earth's orbit. Okay, let's go right here. Let me try something. swap this just so we can see it a little larger. Okay, so we've identified over 10,000 Earth-crossing asteroids, and a little over 1,000 have been identified as hazardous, meaning that they are large enough to do damage. So being 150 meters plus, so 1.5 football fields or 1.5 full soccer fields across, right? And they come within, zero point zero 0.05, right, astronomical units, right? An astronomical unit being 150 million kilometers. So I should be able to do this in my head, but I'm tired. So we're looking at 5% of that. So 150 million times 0.05, right? So bringing them within 7.5 million kilometers of us, right? So those asteroids are thought to be potentially hazardous. Okay. It's worthwhile noting here that 150 meters is 3 times the size of the meteorite that made this crater that we can find in, I think it was Arizona or New Mexico, the Barringer crater. You can see how big that is and what type of force would have created a crater that large. So we were looking at a body only 50 meters, right? Whereas, we've identified well over 1,000 that are triple that size and coming relatively close to the Earth. It's only a matter of time until one hits the Earth, right? It's just probabilities, maybe that something large will hit the Earth. Okay, I'll post these YouTube links, right, into the D2L. You can watch them before, right? And they show a video of a meteor that exploded over Russia, right? And when it broke up in the sky, it released a lot of power, right? And this rock was only 20 meters across, right? So I'm just trying to get the impression that the rocks don't have to be very big to do a lot of damage, and there are rocks out there that are, hundreds of meters across, right? Right, some of them kilometers across, like massive, massive objects. Okay, so I'll post these two YouTube links for you. You can watch them, right? And these are talking about the one that went over Russia. After that Russian one, right, there was a 50-meter asteroid that missed the Earth by 28,000 kilometers. It, that's really close. That's not far away at all. 50 meters, right, would have made a crater like this one, the Barringer crater. It would have it would do significant damage. It would, if it hit a city. Okay, let me move you over here. You can see how big that is. If it hit a city, it would cause a huge amount of damage, right? It would be pretty bad for that local area. It's important to note that none of the known Earth crossers are expected to hit Earth in the next century. That is not how you spell Earth. There should be one T in there. But calculations imply most will eventually impact the planet. So nothing expected within the next 100 years, but eventually, though we're going to get hit again, right? Depending on how big they are. And during a 1 million year period, our planet is struck about 3 times by large asteroids that can do, a significant amount of damage. Okay, so about 3 times a year, you'd expect a relatively large collision. Okay, that can do a fair amount of damage. Okay, it's been a long time since something like this hit the Earth.